This video goes through one question on the AMC Junior paper from 2019. It's question 27, which is towards the end of the paper, and it can be found on page 7. So let's have a read of the question. It says a positive whole number is called stable if at least one of its digits has the same value as its position in the number. For example, 78,247 is stable because a 4 appears in the 4th position. The question is, how many stable 3-digit numbers are there? Alright, so there's a lot of information in here. Whenever you have any sort of problem, you should break it up. Okay, whether you break it up in your head, whether you underline keywords, whether you highlight things, whichever method works for you, but break up the question and find out what information do you have and what do you need to find out. So if you have a look here, I've broken up the question and I've underlined key points. So the facts we're given is that a positive whole number is called stable if at least one of its digits has the same value as its position number. And then we give it an example, and you can see that I've highlighted the 4. Okay, so 4, that number is stable because the 4 appears in the 4th position. So it's got to do with position. And the question is to find how many stable 3-digit numbers. So again, you don't need to underline everything, but it is handy to do that and identify what you need to find. Okay, so this technique is one method to solve it. There is another method, and there's probably more than one other method. I've broken it up into 3 parts, but you might like to condense this. I've broken it up in a little bit more detail. You don't need to show all this detail, but it is good when you are doing some problem solving that you do show all your steps, because it demonstrates your thought process. So being quite explicit in your explanation is a good idea, particularly when we're looking at problem solving. Okay, so the first part, we need a 3-digit number. So we're looking at the numbers from 100, including 100, to 999. The first part, so the stable numbers with the first digit, if it's the first digit, we're looking as 1 as the first digit. So the numbers are 100 to 199. How many numbers are there 100 to 199? We could list them all. We're not going to list them all. I've started to list them. You'll see we've got 100, 101, 102, 103, etc. all the way to 199. You don't need to list them all. It'll take you a very long time. Hopefully you can see that if we were to list them all, we would have 100 numbers. So the stable numbers with the first digit as 1, because that's in the first place we have number 1. We have 100 numbers. Let's look at the second digit now, which would have the number 2. So the stable number would have a second digit as number 2. It is important to note in this part here that we don't need to look at the first digit being 1, because we did that in the previous part. Okay, so now we're looking at the so the second digit being 2. So here the first digit possibilities are 2, 3, 4, 5, 6, 7, 8, or 9. We don't need to include the 1 because that's been included in part A. So the second digit will be 2. The first digit could be any of these options, and the third digit can be any number. So you've got to try and think about how many numbers are there of that representing this. So I'm going to list, I'm not going to list them all, but I'm going to start to draw up a table. So second digit is 2. That's why you can see 2 in red. That is the second digit. You can see the second digit is in 2 for all of them. The first digit can be any of these. So 2, 3, 4, 5, all the way to 9. So you can see I've listed 2 all the way down here. So 2, 2, 2, 2. I haven't done all of the numbers. The next one would be 3, the 3s. The next first digit would be 4s, the next first digit would be 5s, 6, all the way up to 9. The third digit can be any number. So that's why I've got 0, then it'd be 1, then it'd be 2, then it'd be 3, all the way down to 9. I haven't listed them all. You can if you like, but just to save time, because this is a competition, you wouldn't want to list them all. So to save time, we could just see the pattern. So it'd be 0, 1, 2, etc., all the way down to 9. And that would happen all the way down here. The last digit would be 0, 1, all the way down to 9. So 0, 1, 2, 3, 4, 5, 6, etc. So we've got an idea of how many we have here using that pattern. So if we have a look going across, so from left to right, how many do we have? We've got 8 going across, and going down we'd have 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 for we're looking at the last digit. So 220, 221, etc. 222, 223, 24, 225, 26, 227, 228, 229. That's 10 options all the way down. It'll be the same here. So 8 across times 10 gives us 80 numbers. There are 80 numbers that have a stable number with a second digit as 2. The third part to this, let's find the stable numbers with the third digit being 3. This is the third digit. 3 must be the third digit. So you'll notice here I've started with 103, so the lowest. We could possibly start with 3 being the third digit, but I've crossed it out because we've already counted 103 in part A, then 203, then 303, then 403, all the way up to 903. Then we've gone up to, we've done 113, so that 3 is still in the third digit. 113, 213, 313, 413. You'll notice again I've crossed out 113 because we have already counted that. We've used that in the earlier part. So how many options do we have here? 8 times 2, we have 16 numbers. You can count them. Okay, then but they're not the only stable numbers with the third digit as 3. We also need to consider these ones. So with the first digit, so the third digit must be 3. That's why the 3s are all in red. The first digit can be 2, 3, 4, 5, 6, 7, 8, or 9. And the second digit can be 3, 4, 5, 6, 7, 8, or 9. So I've listed it here in a table. I haven't finished the table. I've started it. I haven't listed all the options. I've just put 993 in the bottom right hand corner. But I've listed all the options. So 2 being the first digit, and 3 being the first digit, 4 being the first digit, 5 being the first digit, etc. And then the second digit being 3, 3, 3, 3, etc. And the second digit being 4, 4, 4, etc. So just following the pattern, making sure that the third digit is always 3. If you filled out this table, which we're not going to fill it all out because that, again, it's a competition. We wouldn't want to waste our time doing that. You would work out that you have 8 times 7, which is 56 numbers. So the total number of stable numbers with the third digit as 3 is 72. So 16 plus 56, which is 72 numbers. So to answer the question, we need to add those 3 together. So the 72 plus the 2 answers we got from the previous slides. So in total, there are 100 plus 80. The 100 is from the first slide, the 80 is from the second slide, the slide after that, and 72 is from this side. Gives us 252 stable numbers. This is probably not the fastest way to solve this problem. There is another method, and you can have a look at the solutions if you haven't got it yourself. Give it a go. See if you can find another method to work it out. But this is one way of thinking about this question.